Advent of Code 2025, Day 5, Cafeteria. This is OXDF. Let's take a look at the challenge. Basically, we're in the cafeteria now, and we're going to get a bunch of, there's two sections in the input. So there's going to be, the top section is a series of ranges that represent unspoiled, fresh ingredient IDs. And then we get a list of one per line ingredient IDs. And so in part one, we have to go through each of the ingredients and figure out if they fall within the range. If they do, they're fresh. We need to count the number of ingredients that are fresh. I will say the ranges are inclusive. That's probably important. And that's all we got. So let's grab this example. And that we will, what are we looking for? The example is 3. So let's go over here. We will do Gen Day. I go over this a little bit on my Day 1 video. I should have done it in the intro, but I forgot. So let's see. It basically pulls all my input. It gives me a stub, gives me a place to put the example, like that. Let's take a look at the input. As expected, there's a lot more ranges and they're a lot bigger. And then the IDs are also big. I don't see anything negative. They all look like positive. We could control F for a dash, only 185 of them. And there are how many lines? Hopefully 185. Yep. Okay. So no negatives, just a bunch of numbers. I'm going to assume every range is bigger than every end is bigger than the start, but I guess we'll deal with that if we get to it. Let's go ahead and take a look. All right, so I'm going to actually change my normal thing here. So we're going to do input raw input is equal to f.read, and then we can say ranges comma ingredes equals raw input dot split on new line. And okay, so there, and then I guess we can do that. We'll do that. Okay, that's fine for now. So the first thing we need to do is I want to process my ranges into something I can work with. So we'll say ranges. I guess we'll call it raw ranges, and maybe this is raw ingredes. So ranges equal to, can I do this in one line? Probably not. Let's just do this a little bit. So we'll do for r in raw ranges, start comma end equal to r dot split on that. This raw ranges dot split lines, and I don't care if there's, because I'm gonna normally the thing to know about split lines is it leaves the new line on the end. I don't care in this case because white space, I'm going to turn these into integers and white space is just going to get sucked away. So I'm going to split them here, and then I think I can list map int like that, and now that should take split on there and then apply the int to each thing in it. Turn that into a list instead of there. I probably don't even need a list because the generator will map to this tuple. Let's come here and say, and then we can say ranges dot append s comma e like that. And if we can go down here and for now we'll say ranges, and let's just run this. So uv run day 5 example. We should get some ranges. So we have our ranges here. Hopefully, look, they match that. Beautiful. I should probably do +1. Because we are going to do, well, no, let's not. We might want to do +1 because right now these are inclusive. So we need to remember they're inclusive. So for now, we'll leave it like that. Our ranges look good. So now we can say part 1 is equal to 0 for ingred string in raw ingred dot split lines. Okay. We're going to loop over each line. Ingred equals int ingred string. We'll turn it into an integer. And then we need to say for r in ranges. Actually, why don't we do it? Okay, we can do, I guess we'll do, I was going to say we can make a function, but we can also just do fresh equals false for r in ranges if Oh, actually, we'll do if for s comma e for start comma end in range. If s is less than or equal to in greed is less than or equal to e, fresh equals true. So now we know it's true. We know it's fresh. And then we can break. That probably doesn't matter, but we can do that. And then if fresh part 1 plus equals, oh, in fact, why don't we do this? Make this even a little bit better. We'll do 0 here, and we'll do 1, and then we will do part 1 plus equals fresh. Cool. So that, now we're going to take each ingredient, we're going to loop through all the ranges. If we find one where it's fresh, we set it to fresh and we break the loop. Otherwise, we just leave fresh as 0, we add it in, and when we're done, we may have just solved it. Let's try it. 3, that is definitely what we were supposed to get. 567, glad to see it runs really fast. Boom. All right. Part 2, I'm going to read for a second. All right. So in this part, we need to come up, we ignore the second half of the input, and we just need to parse all the ranges and find all, they can overlap. And so we need to find all of the count of number of things that fall in the range. So like here, 3 to 5, that's 3. Then 10 to 14 is another 5, 10, 11, 12, 13, 14. Yeah. Then 16 to 20 is another 5. But then 12 to 18 is already completely covered. So that doesn't add anything because 12 is in here. And oh, actually it adds 15. 15 gets added by that range. So, all right. So here's how what are we going to do? We are going to, I think we're going to start a completely new loop. Come here and we'll say, so we're going to say for s comma e in sorted ranges. So when we sort ranges, it's going to sort it by default. It's going to take, these are tuples. So it's going to take the first item. It's going to sort by that. And then if there's a tie, it'll take the second item and sort by that. Which is actually exactly what we want. I don't care. I guess the second item doesn't matter too much. It might. Not going to worry about it for now. Probably. So, but because we have sorted ranges, what we can do is we can say, we'll say like idx is equal to 0. And now we're gonna move along the ranges, and we're gonna say we're gonna take the range with the lowest start that's left, and if our index, which is like up to what we've counted so far, is less than that, we're gonna move it up to that. And if our index is greater than that, then we've already had a range that moves into that range. So we're going to stay with the index, and we're going to move the start basically up to the index. And then we're going to check if the end is later than that index. And if the end is later than the index, if it's less than the index, that means it's like a range that's like completely encapsulated. So let's say you have a range like 5 to 10, and you had a range that was like 7 to 8. So if once you process 5 to 10, our index is going to be at 10 because we counted all the way through up there. So the next one we'll see like, oh, the beginning is 7. Well, we're going to move it up to 10. And the end is earlier, so we don't add anything. If the end is later, then we get a process from the index to the end, and then update our index to the end. So I think I just laid that out. I should have typed it instead of like doing it with my hands, and I'm not even sure that's on camera, but okay. So let's see. If s is greater than idx, idx is equal to s. Maybe that's we're changing index. So we've now made. No, let's see. If s is greater than idx, then if s is less than idx, there we go. S is equal to idx, there we go. That'll work. If e is greater than idx, part 2 equals 0. Review. Part 2 plus equals, and what do we want now? We want from idx, we want e minus idx, like that. That seems reasonable. Oh, I still got to search for minus, that's weird. Okay. And then we are going to make sure that we've now idx should be the greater of idx and e. So we say idx is equal to max idx gamma e. I don't feel like super confident in this, but it seems reasonable. Seems like, so we can at least test this. Let's see if our example input 20. I don't think that's right. We're supposed to get 14. Okay. So we will come here and we will do print s comma e comma idx, and then we look at that. So at the beginning, as we read in 3, 5, and index is 0, and we'll say, let's do print e minus idx, I guess. So 3 to 5, and we added 5. That's not right already. Oh, so this would be e minus s, because we updated our s, not our index. There we go. So that might be better right there. 12, we're still not right. Probably, I'm guessing we have a problem with edge cases here, because like this, in fact, should definitely be +1. Maybe? Ooh, that doesn't look good. Unsupported. Whoa, what happened there? Control Z, Control Z, Control Z, S, and this would be +1. 16, still not right. Maybe I should stop just flailing at it and talk it through. Well, I guess we can work it through. Okay, so with the first loop through, we have 3 and 5. S is not less than IDX, so S is going to stay at 3. E is greater than IDX. No, it should be greater than S. There we go. Try that. I bet that solves our problem. Nope. Okay. E is greater than S, 5. So we're going to add 5 minus 3 plus 1. So that's going to give us 3, 4, and 5. That's what we want. So we're going to add, oh, this should be +1. Let's just do that to make sure it runs cleaner. 3. Now the next range we get to is 10. So we should add 5 to that. So that's fine. We're going to do that. The next one's 12. And we should not add. So from 12 to 18, our index is 14. We are going to move up to 14. We don't want to count 14 again. We really should move up to IDX +1, because we don't want to count 14 again. That's probably our problem. I wonder if we need to do that down here too. I bet we need to do that here. Max of IDX +1. No. Okay, so let's keep going. So here we add 5, that's what we want. Here we add 4, because we are going to, 12 doesn't matter, 13 doesn't matter, 14 doesn't matter, 15, 16, 17, 18 do matter. Perfect. And then it becomes 18. It shouldn't become 18. It should be, IDX should become, I guess like that. The edge cases. Okay, let's talk this through again. You're watching me flail a little bit today. So we should, the added thing should be 3, 4, 5, correct. 5, correct. 12, so this is not 12, 13, 14, doesn't count. 15, 16, 17, 18 should. So here we should have 15. Interesting. So we have 15 to 18. Why do we get 3? That is almost certainly our problem, because S is less than index, so it's going to become index +1. I don't think that's right. I think it should be index. Does that mess it up? All right, let's just forget this, all the trial and error. We're going to walk through and try it. So what we're going to do is we're going to start with our ranges, and our range is going to have a start and an end. And these were things that we have not counted yet. So we are going to, if the start is less than our where we up what we've counted to, we've already counted index. So it should be less than or equal index. Then start moves up to index is going to be the last thing we have counted. So start will be index +1. So if we, yeah, that okay. Then if the end is greater than the index, if it's equal, if the end is less than the new, is greater than the new start, then we can add. If it's not, now if it's already, if they're equal, we don't add anything because we've already, where S is things that have been non-counted. Oh, we need to add 1. Okay, so we need to put greater than or equal to, then we add that, boom. Then we're going to update our index to whatever the last thing we have counted, which will just be E. E? The max of E and IDX. Because if E is less than that, we're not going to, nope, max of E and, yeah, IDX. What should that be? That's an interesting question. Okay, so the scenario where we have a fresh range, in this case, S is equal to just S, and IDX is equal to something way lower. So it's not going to matter. E is going to be bigger. in a case where we have an included range, like a range that's lower than we will have, in case we have an included range, so like that would be if we have 10 to 15 and 12 to 13. IDX will be 15, the last thing we counted. S will be 16, the next thing we can count. E will be 13, which is lower. And so IDX should be IDX. Still off by 1. This should be 3, this should be 5. This should count from 15, 16, 17, 18. That's correct. This should then count. So IDX then goes up to 18, to 19. So this should be 19, 20. So that's right. Is 14 the right answer? Have I had the right answer for a few minutes? And okay. I think I might have had it for a while and maybe, maybe just been flailing. I did. Okay. Well, thank you. If you made it this far, amazing. Thanks for sticking with me. Maybe you skipped past this if you were trying to get straight to the Claude section, but this is why, like, we need these boundaries are just tricky, and it probably took me too long, but anyway, we got there. So, all right, let's go ahead and Claude. I'm going to add myself a new terminal. I found that was better. I'm going to Claude. I'm going to AOC 5 for day 5, and let's see how it does. It hasn't taken so long yet that it hasn't been worth like pausing and speeding up. So we'll just talk through. It's calculating the date. It is getting the input. It is getting the page, the challenge. It's seeing that it's already solved. Let's going to see if it's going to try to do it. I don't know why it has trouble. Oh, it's having trouble writing because it's already there. I should give it instructions that, like, if it's already there, just use it. I'm going to add that. I'll add that before the next push, so maybe tomorrow I don't have to deal with that. All right, checking the length of the input. It is reading the input. Trying to find where the blank line is. So lines, okay, so it's interestingly, it's doing the same thing. I'm just going to say yes, so I know what it is. It's doing the same thing we did yesterday, or the thing we did when we look at the input and figure out like roughly what it looks like. Let's see, now it tested it with both answers, and it's going to calculate the time. That's cool. So it got it on the first try, and boom, it did it in 55 seconds. Let's check out Claude. I should do this aside here. We can close you. Claude's solution was about the exact same length as mine. Let's see. It is reading in the data. It is splitting on new lines. It is the ranges is parts 0. Okay, so it's getting the parts. It's getting the raw ranges. It's going to loop through the ranges, just like I did. I wonder if it didn't read my solution, did it? I don't think it did. We would have seen that. Yeah, no, it didn't. Okay. Just like I did, it's mapping ints to line split, working there, and it's appending to there. That looks exactly like mine. Beautiful. And then it's going to say if len of parts. Why are we doing? I guess it's just making sure that len of parts is greater than 1. Okay, I guess it's making sure I can do that. It's mapping. It's getting the. I don't know why. It's getting all of the ingredients. It's then looping over the ingredients. It's checking and it's adding. It's exactly what we did. Okay, so here it's going to do a merge. Okay, so for range, if merged, what if merged? Why would? Oh, I guess if there's nothing. Oh, if there's nothing, so the first time we're going to just append the range. The next time, if start is less than the last item in merge end plus 1. Then we're going to add that one. Otherwise, we're going to append it. I'm surprised. Did it not need to sort them? Oh, it sorted them right here. Cool. And it's going to end up with a set of ranges where then it says, and then it just calculates them over. So we kind of did it in process. It did the same thing, but it actually generated the full list of ranges. We could come down here and do, let's say, like print merged. And now if let's do a split terminal. Cool. UV run day 5, day 05, Claude, day 05 example. And you can see it comes up with the actual remaining ranges. This has got 3 in it. This has got 11 in it. That makes 14. I guess you can see what this looks like on input. It's probably gonna be really ugly, but still, there it is. So all the unique ranges. So that's a good solution. Probably more valuable than what I made, although it doesn't do anything more to solve the problem. So that's it. I'll be back here tomorrow. Have a good one. Bye.